This video will continue section 2.5 by talking about our second method. This will be focused on what we call Bernoulli's equations. What a Bernoulli equation is, one that is in this form. So notice this is very close to first, I guess it's almost first order linear. The only thing that's keeping it is right there. We would have some y, so our dependent variable being on the right to some nth power. If that's the case and everything else looks first order linear, then this is called a Bernoulli equation. If you do n equals 0 or n equals 1, then it would just be linear right away. Otherwise, we can do a substitution. The substitution is the u equals y to the 1 minus n, and the n comes from the power of the y up there at the top, making it Bernoulli. And if I do that kind of sub, then what's going to happen is it will reduce down to a first order linear equation, which we know how to solve. Okay, so First, we see this is a linear, or sorry, this is a Bernoulli equation with n being equals 2. So if n equals 2, then our sub is u equals y 1 minus 2, and that's u equals y to the negative 1. Now, we want it in terms of y because I'm going to have to find some sub for this dy dx here. So if I do some converting here, this is actually just y to the u to the negative 1. From there, we do a different sub than it looks like in the homogeneous equations. From there, like our sub, we would take dy and get the du and all this stuff. But what we're going to do instead, and I think you could do it that way, but here's a quicker way to think about this. Okay, so dy dx. If you remember back in Calc 1, we can think of this in a chain rule type of way where we do dy over du and then du over dx. That's a chain rule. Now, I could follow that exactly from what we have above to get a new equation. Okay, dy dx, that's what I'm trying to replace. And then dy du is just the derivative of this. So dy du, right? And it's just the derivative of u to the negative 1. So the negative 1 comes down, and we get u to the negative 2. So it's negative u to the negative 2. Negative u to the negative 2. And then du dx, because that's what I'm wanting to get it into. Right? So we just do all of our subs. The dy dx over there on the far left is going to become negative u, negative 2, du dx. We replace the dy dx. Then we're going to replace y with u to the negative 1 equals, and then e to the x, and then this is going to be u to the negative 2. All right? I would like, if my goal is a first order linear, then I'd like my u's to be not on the right there. So I'm going to multiply everything by u squared, just to get rid of that side to make it hopefully turn into a first order linear. So let's go ahead and do also a negative. All right, so we're going to multiply by a negative, meaning, okay, I'm going to get a du dx up front. Okay, minus, okay, if I do that, the minus becomes a plus. U squared times u to the negative 1 is just u. And then on the far right, those are gone, and I just get e to the x. All right, and then don't forget the negative has to distribute there at the very end as well. Okay, almost made a mistake there. So now if you take a look at this equation, this is with u being our quote unquote y, right, our dependent variable, this is first order linear. So if that's first order linear, then we're going to do p of x is the number expression in front of our dependent variable here, which is just a 1, which means my multiplying factor, mu, is e to the 1, integral of 1 dx. That's just e to the x. So I'm going to multiply everything by e to the x. So I get e to the x. I'm going to fill in my e to the x with the orange and then put du dx plus u equals, and then, oh, I didn't do that right at all. Hold up. All right. So, yeah, I'm just gonna write it all in one because I'm struggling. All right, e to the x times du dx plus e to the x times u equals negative e to the x 2x. E to the x times e to the x, I just add my exponents. Right? I want to make it look like it's first order linear, so I'm going to multiply both sides by e to the negative x to get rid of the e to the x on the left. But I got to do it on the right as well. So we get du dx plus, right? And we're going to e to the negative x times u. Actually, we don't need to do that. Forgive me. Let's go back. Delete, delete, delete. I apologize. Right here, we're already set up. I was like trying to do the problem as it was at the beginning again. We multiplied by this integration factor. That way we could turn it into this product rule of e to the x, which was our integrating factor times the dependent, which was u. There we go. My apologies. I don't know where my brain was going. I'm even working from notes. So nothing happens on the right side. Just the left side there turns into the product rule. If you're unsure of how that would work out, go ahead and take the product rule the way I wrote it, and you'll see that you'll get the line above it. Okay, from there, first order linear, then we duplicate and integrate. All right, and I'm going to move some things over so I can put my dx, and then I'm going to put it on this side, dy. All right, so now I integrate on the left, and I get e to the x times u. Nothing changes there. And then on the right, I'm going to get a negative 1/2 e to the 2x plus c. You can do u sub if you'd like. And then I'm going to multiply everything by e to the negative x. Okay, so that's going to get me u equals negative 1/2 e to the x, because 2x plus minus x is x, and then plus c e to the negative x. All right, and then the only thing we have to do now is replace u with 1 over y. That was our original sub. And then I guess we could solve for y if you would like. It's not pretty, but y is going to be 1 over that. I guess you could get rid of the complex fraction by multiplying everything by 2. But I'm just going to leave it there because nothing tells me it has to be pretty. So that's how we do those. We just do that sub. You just memorize the u equals y to the, sorry, u equals y to the 1 minus n. Do that sub appropriately, and it just turns into first order linear. All right.